Kia ora class. Today we're going to be talking about the biomechanical principle of Newton's laws. Our learning intention for today is that we are describing how and why Newton's laws affect the performance of physical activity. Now the first question you're probably asking yourself is, who is Newton and why is this important? Why should I care about him? It's a good question. Sir Isaac Newton was an English physicist, mathematician, astronomer, and natural philosopher. He lived from 1643 to 1727, which is interesting. That's almost 300 years ago now. And he was interesting because he discovered 3 universal laws which people could use to determine how things would move in a given situation and explain why things were moving in the way that they were. Now, you should care because these 3 laws are still in use today. They form the foundation for nearly all of the physics that we talk about today, including sport biomechanics, including the physics of what happens to things in sport. Now, his first law, I said there were 3. His first law is called the law of inertia. Basically, this law says that all objects have this natural staying force, which he called inertia. If an object is moving, he saw that it will generally keep moving until a force happens, until a force changes that movement. Similarly, he saw that if an object is stationary, it will stay like that until something moves it, until a force causes it to change. That's inertia in action. He also said that the more mass an object has, the more inertia it has. Basically, the bigger something is, the harder it's going to be to move, and also the harder it's going to be to stop. If you imagine someone drives a remote control car at my foot, it's going to stop. I'm going to be able to stop that real easy. If someone drives a real car at my foot, it's going to be a lot harder to stop. Some examples from basketball performance. In a tip-off in basketball, the ball is thrown up in the air, and Newton's laws say that that ball would keep going in a straight line up until a force acts upon it. The first force to act upon it is obviously gravity. Gravity pulls it back down. But if gravity wasn't there, it would just keep going straight up in the air. Same when it starts coming down. When gravity's pulled it down, it's coming straight down. It'll keep going straight down until it hits the floor, unless one of the players touches it off in either direction. Yeah? So that's the inertia of the basketball. It's going to keep moving in that same way until a force acts upon it. Here, you could also consider the mass of your opposition as related to inertia. If you come up against an opponent like this, Lord forbid, okay, they're going to be really, really hard to move. If they're marking you, you're going to find it really, really hard to sort of push off and get away from them because they're just not going to move. They have so much inertia. Newton's second law, or the law of acceleration. This law basically says that acceleration is another word for a change in velocity or a change in speed, and all objects behave the same when they change velocity. A force is needed to change the speed of an object, the velocity of an object, and that's the same for all things in the universe. The size of the force will determine how quickly an object accelerates. Basically, the more force you put into something, the quicker it's going to accelerate off. And lastly, the direction of the force will determine the direction the object accelerates at. Okay, so if you swing a bat at something, you swing it hard, it's going to send the object flying in that direction really, really quickly. It's going to accelerate off in that direction at the same sort of strength of the force of your swing. Also, if you swing and you hit it and the direction of the force is going this way, that's where the ball's going to go. Some performance examples from basketball. Firstly, a basketball crossover. This is where you are trying to change direction really quickly. Your foot will push off the ground, and the more force you put into that push off, the quicker you're going to be able to accelerate off. and probably the more likely you are to get around your opponent. The more force you can put into, the greater your acceleration as you try and change direction. Similarly, in a basketball jump shot, the force that you're creating will determine how far the shot goes, but you also need to make sure that all of your force is going in that straight direction towards the hoop. If some of your force is sending the ball a little way to the left or a little way to the right, then that's where the ball's going to go. If your force is not straight at the target, then you can't expect the object to go straight at the target either. Alright, Newton's third and final law, the law of action and reaction. Some people say this is the most difficult law to sort of get your head around, but other people say it's the easiest, so I'd be interested to know what you guys think. Basically, this law says when a force is applied to an object, a reaction force of the same strength and the opposite direction pushes back. So if you can imagine there's a force being applied to my hand here, okay, it says that my hand is applying an opposite force back in that same direction, okay, hence they're not moving right now. The force is the same, it's equal and opposite. The more force you apply to an object, the greater the reaction force, and the reaction force always pushes back in the opposite direction to the action force. So action force is the first force, reaction force is the force that pushes back. Now some real world examples from basketball. Consider jumping for a block. When you jump, your legs push into the ground. The direction of your force is downwards, but the body actually goes up. This is an example of the reaction force. You are pushing into the ground, however strong, and the ground is pushing back up with that same strength. Same for a bounce pass. Yeah, when you throw the ball at the ground, that's the action force, and the reaction force will be it bouncing back up with the same strength, so it'll be the same bounce when it goes back up, yeah, and the angle that it hits the ground at will be equal as well. We can see that here. So that is our little summary of Newton's laws. Hopefully you can see how you would start to apply these not just to basketball but to other sports in general.